Good morning, students. So today I am here to discuss regarding limits involving trigonometric functions. So I'll be taking up this kind of questions: how to find the limit where trigonometric functions are involved, and these are very important from competitive point of view. So there are two theorems which are very important. The number one is a theorem, that is squeeze theorem. Squeeze theorem actually gives us the idea regarding limit x tends to 0 sin x divided by x. Now look at the first circle. Here I have drawn the circle, and as you know, this is a unit circle, and wherever I draw a radius and that one theta is the central angle, theta is L by R, hence whenever I find sin theta, then it will be the length of the perpendicular. So if I see the length of the perpendicular, that is sin x is the length of the perpendicular divided by x, or sin theta by theta, their ratio will always be nearly equal to 1. This is the squeeze theorem. There is a proof also when we see this one. Look at the first figure. There are three figures in the inequality. So if I see the value, this ratio sin x by x, it lies between 1 to 1. Hence limit x tends to 0, x by sin x or sin x by x, both will be equal to 1. So this is actually the squeeze theorem. So 1 by 1, when I write limit x tends to 0 sin x divided by x, then the value will be 1 divided by 1 according to squeeze theorem. Squeeze theorem means it is the value is squeezed between 1. So if you draw it geometrically on your copy, you can easily get the things. Now here first thing I told that limit x tends to 0 sin x by x is equal to 1. Now let's come to this theorem. How to find limit x tends to 0 1 minus cos x divided by x. There are various ways of finding this out. So I will be finding out by adopting the method of rationalization or factorization, you can see. Here is the theorem, that is limit x tends to 0 sin x by x equals to 1, I know. Now I will be using it to get the limit of x tends to 0 1 minus cos x whole divided by x. So let us find how to do it. So for that, what we will be doing is, let's start. That is, I know the value of 1 minus cos square x, so hence I will try to make the numerator 1 minus cos square x. So for that, what I will do, I will multiply 1 plus cos x in the numerator as well as 1 plus cos x in the denominator. Now when I multiply 1 plus cos x both in numerator and denominator, the result will be following. So let us see what will be the next step. Here comes, look at this, this will be 1 plus cos x minus cos x, together it will 1 minus cos square x divided by x multiplied by 1 plus cos x. One plus cos x, and here the limit will be set to x tends to 0. Now let us proceed for the next step. In the next step, you see the numerator. The numerator states that is 1 minus cos square x. So what I will do, I will write it as sin square x, and the denominator will be x whole into 1 plus cos x. Now the limit will be set to x tends to 0. Now let us proceed further to the next step. I will be using this theorem, that is limit x tends to 0 sin x divided by x equals to 1. So I will be setting this limit, that is limit x tends to 0. Then I will be writing sin x divided by x multiplied by, again this one will be sin x divided by 1 plus cos x. Now, as per my theorem, the value of sin x by x, or limit x tends to 0 sin x by x, will be equal to 1. This is by our squeeze theorem. So the value will be set to 1, and this is sin x divided by 1 plus cos x will be left with me. Now look at this. If I put x 0, the numerator will become 0 and the denominator will be 1 plus cos 0, it is equal to 1. Hence the entire value, it will be, the first value will be 1 and the second value will be 0, that is 1 multiplied by 0, which is 0. So this is a theorem. Remember, limit x tends to 0, 1 minus cos x divided by x, it is actually equal to 0. So this graph becomes like this, 1 minus cos x divided by x, and when I set the value at this level, please see, then the graph is very closer to 0. Can you see the x-axis? The graph becomes closer to x-axis. So graphically also we can find the limit of this function. Okay. Now, so there are two special trigonometric limits. Two formula you have to remember for trigonometric limits. This is number 1 and that is number 2. Now let us solve this question. Our question is limit theta tends to 0 theta sin theta divided by tan square theta. So I will be using these two theorems to solve this question. So remember, all these questions related to trigonometry can be solved by using these two theorems. So let us proceed now. So in the first step, that is limit theta tends to 0 theta into sin theta divided by tan square theta, I will split it, that is sin square theta divided by cos square theta. So I will be writing here, please see, this one is sin square theta divided by cos square theta. Here the value of cos square theta will go to the numerator and sin square theta will remain in the denominator. So now in the next step, what I will do, I will try to find out the ratio theta divided by sin theta. You can see in the numerator sin theta and in the denominator sin square theta, they are getting cancelled. So value remains will be limit theta tends to 0 theta divided by sin theta multiplied by cos square theta. Here what I do, I will multiply sin theta and divide sin theta. That is the same process which I have told to you. So here what I will get, I will cancel sin theta and sin theta. The things remain will be theta by sin theta and cos square theta by 1. And limit theta tends to 0. Theta by sin theta will give you 1 and cos square theta, if I put theta 0, this will also be 1. So altogether I can have the values to be 1 multiplied by 1, which is equal to 1 again, right? Now remember, in trigonometric ratio you try to bring the ratio theta by sin theta or trigonometric questions. If you bring theta by sin theta in any way, the things will be solved very easily. And this is the graph of this function. Look at this. This is theta sin theta divided by tan square theta, right? You can see the height of the function is nearly equal to 1 at when theta is 0. At theta 0, the height of the graph is nearly equal to 1. Look at this. So this is how graphically also we can determine the limits. Now let us proceed further towards the next question. In the next question I have limit x tends to pi by 4, that is 1 minus tan x divided by sin x minus cos x. So first, what should be done here? Let us see. Now look at this. If I put pi by 4, then this is tan pi by 4 and sin pi by 4 minus cos pi by 4. So tan pi by 4 is 1, so numerator will be 0 and denominator will also be 0, that is 1 by root 2 minus 1 by root 2. So both the things are becoming 0. Hence this is in indeterminate form, that is 0 by 0. So in the last class I have suggested to use L'Hospital rule. So even if you do not use L'Hospital rule, you can solve this question by using trigonometric limits. So use of your L'Hospital rule will make the things easier, but I am sticking to how to split it and show it, because splitting will solve so many questions for you. So let us see. In the numerator I will first split 1 minus tan x as 1 minus sin x divided by cos x. So what it will be? Look at this. For 1 I wrote it as cos x by cos x, and for tan x I wrote sin x divided by cos x, and limit will be set to x tends to pi by 4. Now let us proceed further. That is equal to limit x tends to pi by 4. Now the LCM in the numerator will be cos x, and in the, if I take the LCM cos x, the things will be cos x minus sin x divided by cos x whole divided by sin x minus cos x. And now look at this, I will set it there, sin x minus cos x. So let us write, this will be minus, if I take minus common, because in the numerator you can see cos x minus sin x is already there, so I have taken a minus common. Now here cos x minus sin x is available both in the denominator as well as in the numerator. Please see. So the things will be limit x tends to pi by 4, and here in the numerator and denominator cos x minus sin x will get cancelled. Cos x minus sin x divided by cos x minus sin x, or cos x, sorry, I have written, okay, 1 by minus of cos x minus sin x, right? So here cos x minus sin x will get cancelled both in the numerator and denominator. So the things which are remaining will be, see it here, the things which are remaining will be limit x tends to pi by 4, that is 1 by minus cos x. Look at this, 1 by minus cos x. So, here this will be 1 by minus cos pi by 4, and the things are equal to minus 1 by minus 1 by root 2, which is equal to minus root 2. This is the answer to the asked question. Now, let us see the graph of this function. Here, the function which I have given you, that is 1 minus tan x divided by sin x by cos x. The graph looks like this. Okay. Now, when x will be tending to pi by 4, pi by 4 is nearly 0.785. So, at that case, y value, that is the height of the function, look at this, that value will be minus 1.413651, which is minus root 2. So, this is how we set the limit and we see it from the graph. Now, this is a common question which is asked both in NCERT as well as CBSE exams or competitive exams also, right? So, let us see how to solve this question. That is, question is limit h tends to 0 sin 7h divided by 5h. So, to solve this question, what we will do is, first I know a formula or theorem, that is limit h tends to 0. If it is sin h by h, then only it will be 1. So, that means in the numerator and denominator the same angle must be present. So, if it is 7h in the numerator, I must have 7h also in the denominator, right? So, for that what we will be doing? Let us see the process properly. First, if I put, this will be, this is not equal to 7 sin h, that is very much evident. So, now theorem, we have only two theorems, that is limit x tends to 0 sin x by x equals to 1 and limit x tends to 0 1 minus cos x divided by x is also equal to 1, right? So, what we will do is, look at this, these three things must be same. Again and again I have told you in the class that these three things must be same, then only I can set the limit to 1. So, see, if it is 7h in the numerator, I must have 7h also in the denominator. Look at this, this is 7h, this is 7h and this is 7h, then only I can write the things to be 1, right? So, now using this, let us see how to solve this question. Once again I suggest that if this must tend to 0, first of all h tends to 0 must be 7h tends to 0, and sin 7h divided by, in place of 5h we must have 7h. Okay. So, let us see it. Now, I am setting the limits properly. Remember, when h equals to 0, tends to 0 means the value is nearly equal to 0, and when h tends to 0, the value of 7h also tends to 0. So, let us see, I am getting a delay in the graphics, please see, please wait for a moment. Here it is. Now, I will be setting the things properly. Look at this, limit h tends to 0 sine 7h divided by what I suggested you to write in place of 5h, you should write 7h. So I have separated 5, only I have written h here, right? Then what I will do, I will multiply 7 in the denominator. If I multiply in the 7 in the denominator, I must multiply 7 also in the numerator. So if I close the bracket, the things are like this. 7 will get cancelled and we will have the value to be sine 7h divided by 5h, right? Now limit is set to h tends to 0, right? This value will giving you 1 and the remaining things will give you 7 by 5. So the final answer is 1 into 7 by 5, which is equal to 7 divided by 5. So let us see the graph of this function. This is the previous graph. Yeah, this is the graph of sine 7h by 5h. When h tends to 0, the height becomes equal to nearly 7.7 by 5. So here, this is how we set the limits properly. Okay, that's all for